Okay, now we can start here. So again, I was going to say I'm gone, but I'm gone on Friday. But you can send me email. I'll probably be able to get to it. So yeah, with the recitation, the idea is that you try, and so that you'll make a claim. I'll send that out as a separate thing. I have to figure out how I'm going to do that, maybe with Canvas. It was easy on Cambro, but I'll figure out a way to send it out so that you guys can all you'll basically say is yes or no to each of the 10 questions, whether or not you can show your results for that. And then also you should upload all your, you should like scan everything to a PDF or something, or copy it out into some document, and just upload it into the assignment on Canvas, so that there's also a record of the work. But the way the grading works with recitations is you kind of say that you can do something and then you get called on, and then it's pretty low stress in terms of, if you did it. Nobody ever just fakes it completely and then it's like, oh, I can't do that. No one does that. But so it doesn't matter if it's right or wrong. So somebody asked, do we have to, should we answer the 10 questions on paper and then scan it and upload the PDF? Yeah, that would be one way of doing it. If you have any problems uploading, just tell me, because it should be fairly broad in terms of what document types you can upload. But another way of doing it, I think you want to do this, is you want to actually do it over your own PostgreSQL database, because it's not just, these aren't just paper questions. These are also, this is, you'll potentially have code really associated with this. So do it inside of a, zip everything up maybe and upload it as a zip document or something. Most likely I'm not going to go in and look at these things, but it's nice to have it if I need to. And it's also, it kind of organizes you in terms of kind of getting going through ensuring that you can. All right, one sec. I'm going to turn off my email. It's not wise to just be closed during class. In fact, yeah, okay, that's good. I'll close that too, and I'll close this, or rather open this one, and then get to the slides here. Okay. Well, anyways, I have. Again, it's just a practicality. So that if we need to check, we can check. Okay. So let's get back then into where we were, and or approximately where we were, and then we can talk about some of these things. Let's just do it this way. Let's do a screen. Yeah. Yeah, there's no private messages on chat, so I can screen share temporarily here. Share screen, and it's not going to give anybody. So I'm assuming everybody can see this. Let's move this thing here. All right. Okay. Maybe better if I share a different screen. I'll stop sharing. I'm going to share this screen here instead. There it is. Share that screen. And then I'll just do this. I'll move this in here. And I will say present as a, let me move this first. Present as a slideshow. Oh, I can finally move this. All right, sorry about all this. Okay, now we're all set up. So what we were talking about before, and you're going to cover both of these. What we're talking about before is just this power of putting, of having like a programming language in. You guys can still see my face, right? I'm assuming. The idea of having a programming language inside your database, so that you kind of can evaluate things inside the database itself. And you then don't have the round tripping of all the data from the client, and then also the client, you don't have the issue of updating clients and keeping them in sync. All right, so that's kind of a motivation of these things. So when it comes down to it, then what we have here is we have this is an example function here. or you're actually registering a student. So you're performing an action here with this function. So the to register a student, you have to, of course, have the student ID, and you have the course ID, section ID, semester, year, or whatever. But so what it does here then is it goes in. You have this $sign. This is just a fancy way of making this a full string from here down to here. And what this does then is this kind of, it looks like kind of like a junky language in a way, but it's actually kind of nice. It's a little bit tough to debug, but you can, there are ways you can kind of set things up to increase your efficiency. I mean, I think one of the main problems with PLPG SQL is if you're not like careful about it, you can like go through lots of debugging cycles, or lots of cycles where that didn't work, this didn't work. I mean, you don't want to. It's not that. You should kind of maybe more like look at what you've done and kind of say, okay. I mean, there's like a game you can play, a game you can play when you program sometimes is you can say, I'm going to do this programming task here. I'm going to do this thing. I'm going to like, okay, I know what I want to kind of do. I'm going to kind of build like a skeleton thing. And I'm going to say, okay, now I've got it there. Now this thing, I'm going to look at it. I'm going to kind of do my own syntax check here and say, this should work. Now it's maybe I'll then evolve it to kind of do more and more to meet the actual requirements of what I really want to do. But at least I say this thing works. And so when I paste in to evaluate it, I kind of have some faith that, I mean, it might be a syntax error and then you have to kind of correct that syntax error, but it's kind of like, all right, this is going to work. And then you put it in there and then you test it a little bit and you say, okay, yeah, it's working, or no, it didn't work. And then you figure out why. So that kind of methodology of programming, I mean, when we get to like, sometimes when you get to language where you're really racing, you're doing really rapid development and it's like a language that's interpreted like Python or something, you can really be sloppy doppy and just kind of do things really quick and then test really quick and then go. With Postgres PL/PG/SQL, you probably want to kind of space it out a bit more and kind of like, it's going to be, because when the syntax errors happen and when the runtime errors happen in PL/PG/SQL, it doesn't really good. It's not good about reporting back, and you don't have things like setting breakpoints that you get out of an IDE. So you can't set breakpoints, kind of stop it and check the state of all the variables and all that. You can't do that. So you've got to go back to more the old-fashioned way of programming, where you kind of have to have some faith that this thing actually does what you want it to do when you're going to go through and test it. All right. So people have different methodologies about how they program, but you have to kind of, in PL/PG/SQL, you should probably ease back and go a little more that conservative route. The language itself is, I mean, what is it? I mean, it's basically, you're declaring, it's kind of old-fashioned function. So you have the arguments coming in at the top. You declare what it's going to return. And then you have a begin statement and an end statement, and then your statements themselves are terminated by semicolons. And so even like some of the bracket things like the end if here, that gets terminated there. The end gets terminated. What are some things that don't get? So the if then. So here's a little bit of a problem you'll get sometimes. Is like the actual formatting them is kind of ugly. And it depends on what editor you're using. When I use PyCharm and I have it do its automatic editing of these things, it turns out okay, but not really. It doesn't. It might be, maybe there's like some, maybe if you can find a good style, maybe you can tell me, because it's a lot of times the formatting. But I just do it because I'm already using Charm and it's easy. And Charm does an okay job of doing the indentation and all that. But what you notice here, though, right here, is you have this. You kind of have like SQL statements are like actually built into the language, so you don't have this impedance mismatch. This is actually a cursor, so that's a little bit different. But what you can have is sometimes you can have like when you loop over variables, and I think I'll show some code that I wrote just yesterday that did, like, you just kind of have SQL kind of gets evaluated in line in some sense, but it's a little bit of a funny evaluation model, but it's quite powerful actually. All right, that's kind of how the functions work. Am I getting any questions here? You guys can always interrupt me, by the way, if you want me to, you can put things in the chat or you can interrupt. Yeah, and then to make the call, you typically do it via a select and then a call into the function. There's a little bit of a nuance here, because if you say select star from and then you put it into the table expression, that's kind of nicer sometimes, because that'll also call the function. But what that'll do sometimes, it'll return, if your function is returning a table, because it can actually return a table from your function, then if you do select star from and then the name of the function with its arguments, that can actually wind up being a kind of preferred way of doing things when your functions are returning tables. Yeah, this is right. Yeah, so this is kind of how you. It's. I mean, it is documented. You can go. You can read through the documentation, and I'm actually going to expect you that you'll do that. But then a lot of times it's just kind of trial and error. Getting a sense, getting a feel for it. So you can also put C or Python in, but then this becomes a much more difficult thing to integrate C or Python. So you can build C or Python functions into your kind of running a PostgreSQL database so that they can be used as a server-side function. But it can be you're kind of, if you really need to be secure, and if you know it can be a little tricky. I mean, I haven't done it, so I don't know, but maybe I should try it with Python or C. But yeah, okay. So now we're going to get to one of the main uses of functions, and that is these triggers. So I think I was maybe talking about this example of this more kind of glorified example of Chernobyl or some kind of nuclear power plant and doing the control. But let's take something a bit more prosaic, or something a bit more day-to-day routine. So a lot of times, so there's this notion, you'll hear this term workflow. I'm not sure, have people ever heard like this term workflow? Workflow? I'll spell it out in the chat here. Workflow. People heard of that? Workflow? So workflow is something that is, yeah, it's got a long history of what workflow means. But basically, I'll just give you an example of workflow, and then you can kind of, people use it. It's a very overloaded word. But let me just give you a simple example of a workflow. A simple example of a workflow would be something like this. Like, let's say that you have a database that's doing customer relations management, so CRM, and you have it so that people are on a website. They go to a website, and let's say they fill in like their contact information, okay? Or they go to like a little scheduling app there, and they figure in a time they want to have a meeting or something. Okay, so what does that result in? That results in a tuple being inserted into the database, right? So a tuple gets inserted into the database, and then when it does that, then it should trigger an action. And in this case, the action should be that maybe like a salesperson should be contacted to go back and contact you, or some function should be called that's going to enter in tuples into the calendar of one of your salespeople, or something like that. So I hope that you get the idea. The idea is that somebody does an action, they do something on the database, and then what happens is that causes another action to happen that kind of moves things along in some kind of pipeline. So this is very widely used in terms of like in terms of, well, a lot of tools use these things, but underneath the hood, it's being implemented as triggers. Okay, so but it could be almost anything. But this example of a trigger here, which is not so. Triggers can also be used to maintain the integrity of the database. So, for example, we have a trigger. There's a trigger that I'm going to ask you guys to define, that basically makes it so that when we have this temporal database of trucks moving from place to place, that you cannot have the same truck in two places at one time. Okay, so that's just basically saying that's like a trigger that's waiting for like insert statements on like the truck's new location, and it's just waiting to do something to check whether or not, when you insert a new location for the truck and you specify the time span, that it doesn't clash with any prior, that it's not overlapping any already existing time spans of that have been assigned to where that truck is. Okay, so you can do integrity stuff as well. You can do sales pipeline type stuff, and you can control a nuclear power plant or whatever. You can do like that. This example here, right, is just to make sure that the time slot ID isn't this inclusion dependency between time slot ID and the time slot ID in the time slot table, that gets respected. Okay, and here's the trigger in the standard SQL, and then here is the how you actually do this in PostgreSQL. So let's look at it right here. So the syntax is this: is that you have first of all, let's define the function here. That what this function does is it basically will return what does it return? It's okay, returns a trigger. So it's going to basically be this thing that kind of inserts itself as a trigger. And basically what it says here is it says it returns either null, or it, so not, when a trigger returns null, it means that, okay, that's fine. It's not returning it. It's basically just going silent, so it's not causing any trouble. This right here is going to be where it says that basically if you try to do an insert here in this time slot ID, it's going to basically raise an exception. Okay, but the idea here that where you're creating the trigger and then you say after the insert on section. So you do the insert into section, okay, which again, let's go back here. Section is this thing right here. So you do an insert into section, and it says that after the insert on section, for each row, so that is for each row in exception, and each row here, basically we're talking about is each row in the insert, because you can insert multiple. An insert statement can have multiple rows that are part of it, right? It's with that special values, open parenthesis, then the first tuple, close parenthesis, comma, and then etc. For each one of those, it's going to execute the procedure time slot check one procedure, okay, which takes no arguments. It just basically, but there's implicit arguments in triggers, which are basically you'll always have new, and you'll have new, which is this is always going to wind up being the new tuple or the new row. So new.timeslot ID, okay, so it's because it's going to have that as an attribute. If that's not in, and then you're doing the selection from the time slots, if that's not in there, then raise an exception. And then the idea that if the exception gets raised, what this will basically do, do nothing, or it'll report the exception, and it will not insert the row. Okay, but if it gets past this all, then it'll return null, and then the row will be allowed to be inserted. Okay, so the raise exception effectively mandates a rollback. All right, the function must be defined before the trigger, of course, because right here, if you can't link this at the definition time, it's going to complain. All right, so deletion trigger in PostgreSQL. So what this right here then is that when you delete this, so if you're going to check this, if you're going to get this to work, then not only do you have to deal with inserts here or even updates here. So I have a section that I try to update the time slot to something that doesn't exist, or I insert a section that has a time slot that doesn't exist. I also need to check when I delete a time slot that nobody is pointing at it, right? And that's what this trigger does right here. So this trigger basically will, essentially do this, the last tuple. So it's going to basically block the deletion of the. It's going to block the deletion of the time slot if there's a section that's pointing at it. Right? That's the section that's going on here. Okay, a trigger which propagates. Okay, and a trigger this number of credits are updated when a student passes a new course. So basically what this says right here, it says that create trigger after updating reference row for each row, after update, trigger after update, great, referencing the row. Okay. We can, that's the SQL standard. I should actually remove these from the slides. Create trigger, what this is going to do then is that then we have the, basically, all right, create trigger credits earn procedure. So this is it's doing an update of that. So it's in this case here, raise notice. So you have raise notice inside of this PL PGSQL, and you have raise exception. A raise exception is something that what it does is it will actually force a rollback. But a raise notice will just kind of print a message. Okay, so the logic is a little different there. Okay, all right. Yeah, this is all right. So that covers triggers. That's kind of what I wanted to talk about, triggers and functions. But there's a lot more that's going to be well. There's a lot more to there's a lot more to kind of develop there. There's a lot of details, of course, about how it's an infinite world about different options or opportunities to use these kind of things. So you'll get a chance to kind of work with these on recitation 1. So maybe I can even bring up recitation 1 at this time and just show that so that I can give you guys a little bit of hints, because I don't want recitation 1 to be too difficult. So I take assignments. So it'd be nice to kind of maybe talk a little bit about, here's recitation 1. So in recitation 1, we have this, so this is what you're going to be expected to do. I want you to kind of define, so basically provide the SQL table definitions and why not, and put them into a database. So basically create a PostgreSQL database and then put these guys in. The idea here is that we have a vehicle and then we have a place. So the vehicle could be like, 50 different trucks, and the place could be, you could say the place is like one address in Umeå, another place is like on the road in Umeå, another place is Vindaln, another place is between Vindaln and Umeå. So you have these different places where the truck could be. And then you have, this is a temporal database, because what it's doing is it's basically tracking the place of the vehicle through time. So you have the start time and the end time of the vehicle through these places. Okay. And then you might want to say so something like, so it's granular in the sense it's not giving you like kind of a vector and then you can kind of interpolate exactly where it is on the road. It's kind of just giving more a qualitative description of where the truck is between 2 time points. And so now to kind of respect the continuity of time, by the way, you can say this right here. You remember the old notation in here, I'll just do it, the notation of let's see. Well, you might want to say if this right here is, let me just give a time here. Say, let's say, I'll just do it kind of this way. I'll say 12:21 to 13:45. One sec. People see that right there? And then 13:45 to, let's say, 17:34. Okay, so this is like the old kind of like high school algebra way of just kind of having it so that when you specify an interval, that the bottom bound of the interval includes the value, and the top is taking the limit as it approaches that value. Right? I mean, everybody gets this, right? I mean, this is kind of implicitly how you say, well, what actually happened? I mean, in this case here, you'd say, well, where is the truck? Right on the buttons at 13:45, right? At 1:45, where is the truck? And the answer is, it is in whatever this place is here. It's in that place, right? So if this is, if I can edit this. This is, the first one is place 1 and the second one is place 2, and some smart aleck says, well, where is it at 13:45? You say place 2. Period. Okay, clear enough. Okay, so that then time can be continuous by this kind of representations of the intervals. And then I mean, if you want to get into some like you probably don't want to get into it, but there's this whole Allen's interval algebra, which is kind of an academic way of like looking at these things and what are the reasoning you can do over these intervals. And if I say something like, if I say interval A precedes interval B, but interval B, and then there's another relation like, but interval C finishes interval B. So interval A is before interval B, and interval C concludes interval B. Is it true from that interval A precedes interval C? And the answer is yes. Okay, so there's this kind of deduction that's kind of based on the semantics, and you have these different relationships. I think there's like 7 or 8 of them. The fundamental relations between intervals, and then there's the kind of a closed logic that does all the deductions of the possible relationships. It's called Allen's interval logic. Allen's interval interval logic is vehicle and place in table located in foreign keys and start time and end time primary keys for the same table. So it's just kind of an artifact. So the idea here, the reason why the reason why I would like to be able to actually have an underline go all the way through. So what this is basically saying is it's saying that the primary key of located in is all of these attributes. That's not true. Sorry. The primary key, let me just actually, let's be a little bit more minimalist. Okay, so here you guys can see me edit this thing. That actually can stand as a primary key. But you don't need to declare a primary key. I mean, another way for me to do this is just to stop, just to say this. There's another way. Let's just not even kind of broach the issue. I think this is actually the better way because it's, in general, say less. So what this basically says, there is no, I mean, what's the difference between saying this? Actually, let's say more. What's the difference between saying this and saying, okay, that would be that. Okay, let me just go back to what I originally had. What's the difference between saying nothing and saying the following? So I'm underlining the whole thing. The difference is that in this kind of simple way of specifying things, this will not allow for duplicates in duplicate rows where you just repeating the same information. But let me just get rid of all that and just say this, because it's again, why say more than you have to say? So it's kind of implicit. Later on, when we deal with like the kind of this constraint of like, basically it's what is it? It's like a Pauli's exclusion principle constraint, which, I think Pauli's exclusion principle says that no two objects, well, it says no two objects can be in the same place at the same time. That's different. So that's a physics thing. But in this case, this just simply respects this. We're going to have a constraint that you're going to have to implement here that's going to force the common sense notion that a given truck can only be at one place at one time. Okay, so where was I here? So provide the table definitions for the schema. Okay, that should be fairly straightforward with the foreign keys and stuff. Let's see, valid. No questions there. Insert at least 3 vehicles. So you have to do this kind of manually, and then show, and then in 3 places, and then show at least one of those 3 vehicles visiting each of the 3 places. Right. So you're going to have to kind of in here, you're going to want to manually enforce this kind of no vehicle can be at the same spot at the same time. So this is kind of just a giveaway. Give all the places that one vehicle has visited over a span of time. So for vehicle 4, give me all, and from starting at this particular moment to this particular moment, this time span, where has it been? Where has it visited? So you can ask kind of temporal questions like that. Here we are. Create a PostgreSQL trigger that ensures that a vehicle can only be in one place at one time. So what is that PostgreSQL trigger going to be? It's going to be something that basically says, all right, if you insert a new, if you want to insert a new located in row, then what you're going to have to do is you're going to have to basically say, does there exist a row that's already there for this this truck where the start time and end time collide with the start time and end time, just by doing a simple interval kind of logic. That is do they overlap? Do the 2 intervals overlap? And that's that's actually, overlap is one of the predicates in the interval, Allen's interval logic, by the way. But you could just kind of get it by just putting the SQL conditions in. So if that's the case, then reject the input. Okay, does that make sense to people? I hope. That's if you are going to, now if you say, well, all right, then what about if I do here? I can maybe make this easier. Create a PostgreSQL trigger that ensures that a vehicle can only be in one place at one time. Okay, I think I'm going to make you guys do the whole thing just for this, and that is that what that also means, it means that you have to deal with updates as well. So you have to have, you're in fact going to have two triggers. You're going to have a trigger on insert, and you're going to have a trigger on update. Because if you have you have two tuples in there, and then you kind of expand out the end time of one of them, and then it winds up colliding with the second one, then you need to let's see. So if start time doesn't belong anymore into the primary key of a car cannot park at the same place multiple times. So if start time doesn't belong to the primary key, a car cannot. I think it will go the opposite way, because I think that when you take away these constraints, it just means that you're even more permissive with what you allow in there. So I don't think in either of those cases. Okay, this database should absolutely allow for a vehicle to visit one place, go and visit another place, and then at a later time revisit the original place. Okay, that should be expressible in this simple database. This is a temporal database, so this is like it's not normally you deal with snapshot databases. So let's contrast this with a snapshot database. So a snapshot database would be a database where you basically just have a foreign key from vehicle to place, and as the thing moves from different places, you just update that value, right? That would be, but then you could not ever look at the history. You would only have kind of what the current place of something is. Can you miss SQL, PostgreSQL, and PL? Oh, I see. That was a private message. But anyways, okay. Okay. First of all, so the question, it's a good question. Okay, can you mix SQL, PostgreSQL, PL, PGSQL all in one place? Yeah. I mean, it's a good question actually. So let's just say SQL is just the standard. I mean, SQL is really, it doesn't, SQL in the abstract in its definition doesn't do anything. So we talk about the SQL expressions that we're pasting into PostgreSQL. Yeah. So what you wind up doing is first of all, you have a file where you kind of develop this stuff on the side. So let me see. I might have might be getting ahead of myself a little bit here, but let's just go here. Where is it? Open. Yeah, by the way, so somebody else asked, so there's no primary keys in the table located in. Yeah, I've got rid of them. I don't think it's important. You could, if you wanted to make a primary key, you would make it this. But I don't, I mean, you'd make it vehicle, place, and start time, because that would actually determine end time. But I don't think it's even worth declaring that. So that's, generally speaking, if you're not going to get anything out of making things more complicated and declaring stuff, just always do the minimal amount. That's just a general. That's the way I would encourage people. Because I mean, generally speaking, the more you have written, the more you have to specify, the more places things can go wrong. All right, let me just get this. Let me just show you how I would work. Okay, so you guys can see this, right? This screen is being shared. Can you guys see like a pie chart thing? Good. All right. Here, I was just dicking around here with this. So basically, the way I do it is I have like a file that I would call like warehouse.sql. And then what I would do is then I would bring up something like following. Let me just get this bad boy here. Oh, there it is, right there. So then I have I open up, I don't use pgadmin. I use just PyCharm with SQL in it, and just a terminal that this, okay, so let's take it from the top here. Okay, so here I am, and then I say PSQL rec1. That's a database I've defined. And I can just maybe, do people want to see me just doing this from the very beginning? Maybe that'll be kind of helpful, because what I'll do is I'll just kind of, okay, so now there is no database. All right. So what do? I would say something like this. I would say, okay, create DB rec1. Okay. Then I would say, bring me into that. Right. Then I would say, okay, show me the tables. There are no tables. Okay. Now I'd go up here and I'd say something like this. Oh, here's my SQL. I have this thing called a product, and I'm going to create the table, copy, and paste it in there. So another way of doing this, of course, is you can say, like, if I have this thing as a full file, I want to run everything inside this thing. What I could do is I could say basically \I. What is this called again? This is called warehouse.sql. I could say \I warehouse. Okay, and that would load the whole thing in. What the hell? I'll just do it. Okay. So now if we look at the tables, we have, so basically it went and it executed all this. So I had product, and then I have store, and then I created this table of sales, I guess, I hope. Yeah. And then I made a function here. So this function make data here, that's this right here. And see how it kind of munged up the like create or replace function make data. It's not the prettiest way it kind of did the actual indenting, but this is a Postgres. This is a this right here is a PLPG-SQL function. Okay. So what this basically means, it means that I've done everything in this file here, but I'm just kind of defining it here. And what this one does here is it makes the data. And so what is it doing? It's going to go through this thing here. We'll touch this in a second. It's going to go through this whole thing, and it's going to just between this time. Okay, I could update it to like between, well, June 1st, 2021 and August 31st, 2021. It's going to basically generate all this data. I'll go into this a bit more detail, but and then I got some other stuff there. But it looks like what I need to do here, like right now, if I say select star from sales, it should be empty. But if I say select star from product, it'll, you know, there was a data was in the file. But now if I say select make data, then, so see, did you see how fast that ran? Did you see how fast that ran? And then just look at this, select star from sales. It created all that data in that. Well, actually, that wasn't that much data, but I still think it's kind of impressive that, I mean, things are just so, you know, so fast now. Okay, let's see. So I just the reason why I just showed this, I just segued to this, is I just wanted to show you this is how I work. This is how I would work through recitation number 1. Okay, so but if we go back here, I guess what I should do is I should save this. And let's see here. What do we do for time? So in this case here, right here, is I would, okay, now I would create the trigger. So I would create the function just like I showed me creating the function, not that. Just like I showed me creating the function here. Create function here. I'll create a function that basically would something, maybe it would say true or false. I mean, does this violate? Should I throw this function? Basically, you put in the, you know, with the new row comes in, and then that is the new located and comes in, and it checks it, and it says, does it violate any other? I mean, is it clashing with any other rows? And if it is, then it will throw an exception. And then I would create a trigger that uses that function. All right. Now, finally, here we have create a function that immediately moves a vehicle to a new place. Record the start time as the time when the function is called. All right, so this kind of really kind of brings in, how did that happen? This little thing right here, I don't like that. I'm going to edit this again. I mean, these are things that I don't like it when things look scrappy. Look there, it's not scrappy. The function called. Oh, maybe it was scrappy. Yeah, there it is. It's better now. So create a function that immediately moves a vehicle to a new place. record the start time as the time when the function is called. Okay, so let's say I have a record. So this brings up several issues. So one issue is the following. That is that now in temporal database theory, you have this kind of valid and until changed or now. So they'll say something like this. I'll say if let's say that basically Michael's place is okay. So let's say that I'm in Umio from let's say time 12, 30, 21. Let's see, what time is it right now? I'm actually not in Umio. I'm in Omsala. And I say from, let's say, some time 9 in the morning. I'll make it, I'll do it in this to now.
Black, Michael.
Oh, yeah. The window's just black?
Or what you were writing. We couldn't see what you were writing. We only see a black frame and the recitation.
Oh, I'm sorry. I think the reason is that I know the reason now. That's actually kind of smart of them. So the reason why they did that is what they've done is they blocked out. They have it so that you because there are private chats in there. Actually, yeah, there are private chats. So it was not letting you see those. That was the reason why I blocked it out. Okay, but if I say this now, did everybody get this? Let's see. I'm just gonna. You see that in the chat now? Okay, good. All right. So that says basically I'm in Omsala from 9 o'clock till. All right. I mean, I could say I'm in Omsala from 9 o'clock until 10:57. What's going to happen when it becomes 10:58? No. How do you represent, now, like now? Okay, now let's basically say here's how it actually gets represented. Here's how you actually represent it in PostgreSQL. I know it's lame, but it's the way it is. In Omsala. Okay, first of all, these aren't just timestamps. They're actually, I mean, these are timestamps. So they're basically giving you the full date. So basically what you would say you would say something like this. You would say 2021, I don't know, what's the date today? 09, 05? Is it 05 or 06? I don't know, whatever. And then I'll say 9, okay. And then what do I have? The only option I have now, here, I'll show you guys this in a second. You'll see it. The only option I have now is to say, this is a common trick. Something like this. Okay, people see that? Because, I mean, you can have a null value there, but that's kind of, all right, maybe a null value. You decide what you want to do. But the idea is that you'll see that this is kind of a common way that you either have a null value or you go in and you make your, I mean, unfortunately, I don't think they have a constant for now in timestamps in PostgreSQL. I can check on that though. But you get something like this. So basically that you'll have a record of that. Okay, now in number 5, if now I say I want to move to Umio, I want the place to be Umio, then what I have to do is I have to go in and let's say effective immediately. So I take whatever the time is that I'm saying, move the object to Umio now, and I have to go and I have to make an edit to that one tuple there and give it a valid end time of now, and then insert a fresh tuple of the new location, and then give that the current time, and then have that end in year 9,999. Does that make sense to people? So you have to be a little bit clever about this as you update, when you do the updates. But what this would allow you to do, it would allow you to do simultaneous updates to kind of keep the simulation in track with real time. Okay, I mean, it's not that hard. It's not so difficult to do. All right, so what we're going to do now is we're going to take our break, and then we've essentially covered. I'm not going to go over recursion because we already did that in the first class, and it's not really that high pry. Maybe if I get time at the very end, we can go back and look at the recursion stuff. But I want to go over into data warehousing, which I think is much more relevant. So let's get back at 15 after, and I'll just pause recording now. I'll mute myself first. Okay, folks. I think we're back now. All right, I'll do a screen share. All right. So I don't see any questions in the chat, so let's assume that's all fine and good. So now what we're going to talk about here is kind of one of the how would you say this? It was one of the main uses of databases these days, data warehousing. So we'll kind of we'll just kind of jump right into it. So basically, you can make a distinction between usually two different kind of like types of databases or uses of databases. There's what's called OLTP, which is what stands for online transaction processing. And what this is this is kind of like that trucking example, or like the example of like you have like people working cash registers. So it's actual transaction data. It's data that's basically happening in the modeled reality or the world that's being represented. So yeah, it could be something like I mean, in the example in recitation, we'll see that the OLTP is the actual purchases of customers at the registers, right? This is contrasted with the OLAP, the online analytic processing use of databases. And what this has to do with, doing like analyzing trends. Okay, so analyzing like what has been like the trend of the sales of a certain product in a particular set of stores over a time span. It doesn't have to be commercially related. It could be also something like what is the it could be like something in like science or experiments or something like what is the trend, like what is the number of like these samples, what's happened to the quality or the results from the samples, or the number of samples or the number of this type of sample or that type of sample, how they developed over time, and we want to see kind of the trends. So there's kind of there's historically there's this Kimball, Kimball way of doing things, which is kind of the classic way of doing things, and that is to kind of do these OLAP systems in what are called star schemas. So we'll cover that here, and then we'll talk a little bit about a alternative to that. Now, the whole thing of going from so one idea, of course, would be to simply say that, well, we just have one database, and part of the tables of the database are used for the online transaction processing, and the other part of the database is used for the OLAP, and that's fair enough. I mean, that can happen quite. Yeah, that's quite common actually. Historically, though, there's been like really because the performance was such an issue, especially in the OLAP systems that have so much data. There's been a lot of I mean, there's this ETL process. You'll hear a lot about this, the extract, transform, and load process, which defines how you take data from the operational database and put it into the warehouse, and put it into the OLAP system. That has traditionally been kind of a complicated process. It's been radically simplified though recently, and we'll cover that in recitation as well. So it's getting simpler. This ETL process is getting quite a bit simpler, which is nice. All right, so maybe what I'll do is I will go back to recitation, because I think that'll kind of drive things a little bit here. So let's look at the recitation problem for the warehouse here. I trust everybody can see this, but I don't want you to see that. Although, that was my email. Okay, the OLTP database here. So that's the transaction processing database. What it has is it has a transaction. So this is one, you have a bunch of stuff in your grocery bag. You go up and you put it, you have them and they scan it, and then that's going to stand for the transaction. So basically what that is that it's going to happen at a particular time. We're going to give it a transaction ID. All right. So this is basically, yeah, that's a typo. See, we can go in there and edit this. That is definitely a typo. Edit. See if there's any other, not sure anybody else recognize that. So the transaction, the store is not part of the primary key. So at a particular transaction ID is going to determine the time it happened and the store where it happened. All right. Now the items, they're going to basically say they have a foreign key to the transaction that they're a member of, and then they have, a product, and then in a quantity. All right. So actually the time, the transaction ID and the product actually does determine the quantity. Right. So, transactions are not going to have, I bought 2 Cokes and I bought 1 Coke also. It's going to basically say 3 Cokes. That's how that gets defined there. All right. So this is, so what you could do here is you could set this up and you could have it so that as they're ringing up things through the register, then we're getting a record of all the things that the customers are buying. Right. So that's very transactional. Right. So in a real system, of course, it would have like the amount of money collected, et cetera, et cetera. And then who they got billed to, a lot more information, but you get the idea, I hope. All right, so even part of this transaction database, we have like these tables here, this product table, which gives us an ID of the product and then the name and type of that product. And then the store, which is an ID, a name, city, region, and country for that product. I'm sorry, not for the product, for the store. So the store has a name, city, region, and country. And what you'll notice here is you might say something like, well, we'll have one store. We have let's say we have 20 stores in Umeå, right? So then we have Västerbotten and we have Sweden. And then, you might say that doesn't, Västerbotten, Sweden, that's another functional dependency. Shouldn't that be normalized out? And the answer is yeah. Actually, if you want to stick with normalization theory, it should be. So this is not in third normal form here. This is in because there's transitive, region functionally determines country. So if you wanted to go to third normal form, you should actually partition that out. So some people actually will take things to third normal form, and that becomes a constellation. All right. So or let's see, star schema basically becomes the structure of the schema becomes it's not just a single. I'm sorry. I'll get to that in a second. So that's the OLTP right here. This right here is your online transaction processing. Well, no. So somebody basically said, so a transaction says nothing about what was purchased. No, not true. A transaction just sits there, and the things that are purchased are in the item table. So there are a lot more items than there are transactions. But I might go to the item table here, and I see that I have a transaction ID. So let's say that I purchased apple juice, orange juice, and bread. Then it's going to have, in one transaction, then it's going to have that one transaction, and it's going to have 3 items, 3 item tuples. Is that clear? And also the notion of transaction here has nothing to do with database transactions. Okay. It's a transaction, kind of the classical notion of a transaction. Okay, but these are good questions. So yeah, keep them coming just to kind of get it clear. Okay, so that's the OLTP. Okay, but now let's say that somebody down in Central says, yes, but what has happened to the sales of toothpaste, and not just toothpaste, but this particular brand of toothpaste? How is that? Can you give me the total sales of that toothpaste in Umeå over the last 6 months? Because 4 months ago, they started an advertisement campaign where they wanted to kind of sell that toothpaste. So they're expecting to see a bump up in the sales of toothpaste, right? Starting about 4 months ago. So so that when they ask that question, they're looking for doing trend analysis. Okay. So that's a different use case, right? So, meanwhile you have, so it's like, well, all right, fine. How are we going to actually be able to support that. And the way you support that is you have this fact table. All right, so a fact table is in the center of all this. And what a fact table always has, it always has one attribute, in this case, quantity, which can be summed. All right, something that can be summed up. So that's kind of the thing. It has to be either, usually it's either like the number of something, the mass of something. It's something that would make sense to sum. All right. And in this case, it's the counts. So we're in the sales table here, we might have in a particular year, on a particular month, that the product, that particular toothpaste was at the preem, that toothpaste was 14 of those toothpastes were sold in that month. And we, the truth is, we can even make it even more. So we have year, month. Here, let's we might as well do this. Date. I don't want to make it, but anyways, I could break it down. I could make it down. I could take it down to this level of granularity here. Now, this is definitely not with it, because date determines month and date determines year, right? So what this basically says, there's a lot of redundancy here. So this is definitely not in third normal form here. But what this could say, it could say on this particular Tuesday, on particular Tuesday in July of 2021, 3 of this particular product were sold at that particular store. Okay, so it's very, very detailed data. I think, should I leave it that way? I mean, this could, yeah. I'll leave it this way. It's easy enough. It's what's nice about this is going to make it so that sales has a lot more data in it, because if we're aggregating, we're basically rolling up by the month here. If the date's not here, then the sales table itself, like that's the actual basis of the warehouse. It's a bit too wide granularity. We want to have more fine granularity, because maybe we want to do something like this. We might want to say, okay, show me by day of the week, whether it's a Tuesday. I want to see what are the, I mean, I don't care what month it is. I don't care what year it is, but I want to just see it on how does this thing track? So it might be that like we find out that the toothpaste really sells high on Thursdays and Fridays, as opposed to, over the years, it really sells a lot more on Thursdays and Fridays. All right. So to get to that, we would want to leave the date in here in the sales. So we want to have a lot more granular data. But at the same time, what that means, it means there's going to be a lot more data here. And let's say we have 1,000 products and we have 1,000 stores, and then we have, every day, and we can even take it down to if you really want to get wild here, we want to take it down to a timestamp. All right. And then we have an extremely large, sparse data cube is what it would be called. Okay. I mean, does this make sense? I mean, it'll make more sense maybe when I go over the lecture slides, but I'm just trying to give you an idea of kind of what this table right here, now that I have year, month, and date, the exact date of the product in a store and a certain quantity, that's going to be a big table. And the point is, but is this table, can you derive this sales table from this transaction database here? Can it be derived? That's a question. Is there enough information in here so that you could populate this table here? I mean, I think that if you think about it, I think the answer is yes. And in fact, I'm going to ask you to write a view, an SQL view that defines exactly that defines exactly this table from these tables. All right. You only actually need, you'll see kind of how it goes when you do it. Okay, so when you declare that view, then again, you always have the choice, right? You could declare that view, you could declare it as a view, you could declare it as a materialized view, or you could declare it as a table that you then populate with an SQL expression, which is essentially that view, that just basically moves it over into that table. So those would be your 3 options. The third option, why would that be kind of maybe the best? I mean, why would that maybe be the best way to like just actually copy it over to a fresh table? Well, because this might actually, if you're using transaction in the database sense, transactions, if you're using those to do rewrites on the base tables here, then maybe what happens is that you generally, these are always going to be read queries. So you might get some contention there, but the thing is, in general, sometimes, I mean, when you're talking about really giant places, they put them on two different systems because they have the management people up there doing the kind of the analysis and what ifs, and then they have people in the operations who need really high performance. So they basically segregate this into two separate databases, and that's where the ETL becomes important, because then they do the transfer. They do the transfer of the data back, from the OLTP to the OLAP. All right. So I hope this makes some sense. We'll get back. I'll come back to this right here, but let's just go back to the lecture here. So, all right. So basically, that right there kind of shows you, hopefully gave you some motivation, or shows you a little bit what we're going after here. So if you look right here, this is a star schema here. So this is very similar to what we had just a second ago. You could have the date. Basically, what you could have is you could have the date here in the actual sales table, and then that points out to date info here, where you've broken down all the dates into their month, quarter, years, maybe even day of the week, or whatever else you might want to have. So this is a Kimball. It's called Kimball. If you read that textbook that I listed in readings, you'll see that they're talking about Kimball. The Kimball approach you break things out into a star schema. All right. And then if you want to, you can get, it's called a snowflake schema. I was kind of blocking that. If you want to go out to third normal form, you can even have a snowflake schema. So it becomes broader. All right. Okay, so here's a simple example that I don't want us to kind of deal with so much, because it's I think it's just I'll be able to show you this in in kind of real life on roll-ups, internal representation. So I just maybe should say this right here, that a lot of times this gets visualized as a data cube, which is kind of mostly based on the historical development of this. So what you have here is, like, you can see this. This would be it's called an n-dimensional hypercube. So the idea then is what you have like all the different item names, and then you have the different colors, and then you have the different sizes, and then you have a distinguished all, which basically says, it does a roll up. It basically does a summation across. So this 164 here should be 77 plus 42 plus 50, 45, right? That should be equal to 164. So it's totaling across here. So yeah, I mean, just looking at this right here, it's pretty clear this is going to be 48 if you add those numbers together. Okay, so what is the idea behind this? The idea behind this is that really, if you think about it, kind of like maybe you all had this kind of feeling when you went to like if you basically say this, if you say I have like sales. So let's say that I do this. I say 0 to 10, 0 to 10. Okay, this is going to be kind of a little bit. This is a little bit tedious here. I'll just do it there. Okay, so if you look there, that right there is a multi-dimensional cube. So I'm sorry, I should have said this. I should have said. Let's say you went to like your favorite programming language, and let's say it was like. If I say sales, how do you do it actually? Gosh, I mean, all right. All right. Oh, that was only 2 of them, darn it. Okay, anyways, if you can imagine, I could put like sales int 10, 10, 10, you know, this, I can basically define a hypercube in C. Right. Okay. I hope you guys get the idea. So in your normal programming language, I mean, you can have like multi-dimensional arrays, right? That can go out to any, you know, and you can put any arbitrary number of dimensions on the array. And so that kind of was the underlying data model behind this. So originally this stuff is interesting. It has an interesting history in some sense. I mean, this data cube and kind of summations across here. Sad to say, the original use case of this was the body count in Vietnam. So the econometric stuff that got developed in the 60s was all kind of based around this. So, you know, you would have, so it's kind of a nasty origin story. I'm not really sure exactly what that, but I think it came around that time. But they were into counting stuff. So, but God only knows. Anyways, back then they didn't have relational databases, but they did have multi-dimensional array definitions. Okay, so rolls up, OLAP, drill downs. So you can kind of like imagine that you could sit there and you could say that, well, I want to, you know, like you could have like, let's say this, you had date on one of the dimensions here, and then you wanted to roll it up into months. So that would kind of sum everything and do like kind of a squish down. That's kind of like maybe like, I mean, this stuff is kind of in flux. And let me show you, what did I do? All right, good. So I think that now we can just go over to an example, and this will give us a bit better insight. So we go back to the so write an SQL view that defines the OLAP fact table from the underlying. Okay, Kimball, use joins to calculate the total number of products of type soft drink sales per store in 2020. All right, so what you can assume here is you can assume that the product and store tables are dimensions. So if you notice here, what we have is we have sales. That's our fact table because it has quantity here. And then from sales, what we have is we have, let's see here. From sales, we have foreign keys that go out to the product and to the store they're being sold at. So maybe what the best thing to do here is just to kind of us to go into the SQL database here. Okay, because this will give us a little bit more intuition about this. All right, so how did this thing? What was this whole thing about, by the way? So what it was about. So now we have sales. So if we look at the sales here, so if I say select star from sales, then we have a date, and then we have the PID, product ID, and the sales ID, and then the quantity that it was sold at. So on this particular date here, on June 1st, in store number one, I'm sorry, product number one, in store number one, we had 88 of these things sold. And so that is product number one, store number one. So let's see, select star from product. So we have 88 Cokes, and then let's see what store it was. At Preem, right? So that's a record there. So when we do, when we look at the sales, we just have a record of the date and then the product and the store and the quantity that was sold. Okay. All right, but that's not what we would like to see is we would like to see something like what is the total number of products of type soft drink that were. So let's see. Do I have that? So let's see here. In 2020. So let's say if I just go over the span I have here, if I say something like this, I say sum. If I say count star from sales where, and then we see Coke right here, and I'll say group by PID. Right. So why does that not work? Because I need to, in here, I need to say what the PID is. Okay. Is that true? That can't be true. What's going wrong here? What am I doing wrong? I'm doing something wrong. One sec, sorry. Oh, what am I doing wrong? Can anybody tell me what I'm doing wrong? I mean, I'm just being stupid. Why am I being stupid here? That's a question for the ages. One sec. Where's my chat? Where did my chat go? Here, chat. Oh, please. Where is the chat? There it is. Why? No, it's I mean, this will be, I mean, you could sit there and said this, you know, that, I mean, I showed that basically I'm sitting here just like, you know, well, I know what I did wrong here, but let's see, does anybody else know what I did wrong? It'd be kind of interesting to see if somebody else can, if I say count. All right. So when I am going to do a group by, when I'm going to do a group by SID, so I'm going to group by stores, right? And that's going to partition it into, I mean, they all have, listen, a store, every day we're recording for a given store, we're recording all the products. Even if there are zero, we're recording them being, so if you look at here, even if there are zero that are sold, then, but we're still making a record of it, right? So what this does, this is kind of what I'm doing that's stupid here. I'm saying, how many records do you have? How many records are there of sales per store? You know, I'm going to group by, you know, group by the store. Well, the answer is, well, it's just however many days there were times the number of products there are, and that's going to presumably is 460. So what I need to do instead is I actually need to sum the quantity. I knew it was some aggregate function, but I got the wrong one, right? So now that actually is telling us something that's more, that's meaningful. It's telling us what are the total number of products sold in store 1, 2, and 3. All right, that's what this. So I've repaired the query here. So now if I say, all right, give me the quantity per product. Then this is the quantity per product. Now, what if I say something like, well, I don't really like the fact, I'm going to basically say order by product ID. Okay, so there we are. So, but yeah, so that's all fine and good. I mean, this is not a problem, but we're just dealing with the sales table, right? So what if we want to make it so that what we can do is what we want to do here is we would like to actually be able to we'd like to actually get a hold of the actual names of the products because this PID, you know, that's not very informative. So what I would need to do then is I would need to say something like name from sales product where sales dot PID equals product dot PID. And then it's not going to like the ordering by the product ID here because it's ambiguous now, right? Yeah, see, the PID is ambiguous because there are two PIDs. There's a PID in sales and there's a PID in product. So what I need to do then is I need to do something like I'll basically just say group on the name. So the product name. All right, so now we have like 7-Up, Bula, Coke, Magnum, and ice cream sandwich. All right, so okay, so you can get to these things via SQL. Now, if I wanted to do something like I wanted to say, give me the, if I wanted to say something like, give me the, let's say, okay, let's see, what was the recitation question that we had? It was something like, so I'm assuming this turn that's black, right? I mean, are each of these little fields now black? Where did my chat go? Now I'm getting annoyed. Oh, my chat was what I just moved over. Yep, they're black. Wow, that's nice. So the chat, yeah. So yeah, I guess Zoom can do that because they they own the whole platform. All right. Okay. So use joins connect the total number of products of type soft drink sales per store. So I mean, you can do this, right? And I can go and I can do more and more joins and more complexity. But the thing is that what people say is they say that that's this is what the queries wind up looking like if you use the Kimball approach and you do the joins. So you have a star scheme and you're doing the joins. So there's another alternative which has become much more popular now, and that is to just do the following. So let's just instead do the following. Let's okay, I'll just call it wide. And I'm going to create a view here. All right. So what is this view? This view is basically get the store name as store. So basically, it's joining all of our tables together: sales, product, and store. Right. So we're basically forming everything into one. Into one wide table. All right. So now, the view is defining one wide table here. So now if I say select star from wide, all right, we have store, product, type, date, month, quantity. And as we see here, this is really kind of crazy in terms of like, this is not normalized at all, right? Because, we have, like product, Coke is a soft drink, Coke is a soft drink, Coke is a soft drink. So this is really, this is basically the universal schema. This is before any kind of normalization, but that's fine. So, well, people would say that isn't this just like, if you actually put this into a table now, if I actually, instead of just making it a view, I actually dump it into a table. And how would I do that, by the way? I don't have the time really to do it right now, but what I could do is I could, basically, let's say I created a table. So create table, blah, 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 which is basically giving a store, product, product type, date. And then I basically then would say this. I would say select star from wide into wide table. So what that would do is that would actually populate that table. So then we would actually have a table. Now that table would look just like wide. I mean, it would look like that, but it would actually be, instead of being derived from the view, it would actually have all the, everything would be sitting there as kind of on disk, right? It would actually be physical. I mean, there'd be a physical rendition of the view into tuples in a first class table. All right. So then we could index it. We could do a lot of different things with it. So it might actually make a lot of sense, but it would not make sense in terms of like, it's pretty redundant because we're just, it's not in good form normalization wise, but we don't really, we just kind of say, okay, we don't care. But if we do it this way, then we can do things like this. We could say basically, all right, I could say like, I mean, the easy things for me to say is I could say something like, okay, I want this, like the sum so give me the quantity per store. Do Why have even month there? Yeah. So, oh, by the way, that might be something kind of. You see how I was using a function here to pluck out the month, right? So that's kind of that's. So if I basically say this, I say now select that sum the quantity for the store. This okay. This will give me an error, but I don't care. Okay, I'm going to basically say select. From wide group by store. Okay, so this gives me that this is like, so that's a lot simpler way to plug out the store name and just to do the sum without having to involve any kind of joins. So this is the reason why wide tables are being encouraged, or this is one of the main benefits. But even a nicer benefit is the following, and that is we can use, in a very easy and elegant way, we can use this group by cube syntax and watch what this does. All right. Actually, that's not the one I want to do. I want to do this. Sorry, this will make it clearer. All right, so I'm going to select this, like this, the total quantity, summed quantity for store month product from wide, and I'm going to do this group by cube here, and we'll see what this group by cube does here in 1 second. And then what this is, it's pretty nice. It's going to calculate all of the possible combinations. So with this right here, what does this represent right here? This represents that there's a total of 6,281 7-Ups that were sold in June in Circle K. Okay. What does this show right here? This shows that, so now it did, when it's doing the grouping by cube, it's actually forming that cube that has the roll-ups, the aggregates kind of computed within it. So what this right here is now this, it's saying right here now that, all right, first we did a grouping by store month product. Okay, fine. And then we did a grouping where we left off the product and we're now rolling up on product. So what this basically says, it says that forget what type of product is now, because that's left as a null. Yet another example of a null being used. We have in June, Circle K sold 41,449 products. Okay. And as you'll see down here, we even say, okay, that's in June. What about Circle K's total over this whole period from June, July, and August? So we'll find that too. And where is it? It's, there it is. No? Circle K, where are you? Over all, the whole span. There it is. Well, let's see. Yeah, Circle K, how many products did you sell? So null, so it's basically rolled up on the month and it's rolled up on the product type, and it's 122,107. And if you want to say that, okay, forget over the 3-month period, how many 7-Ups did you sell? Well, now it's rolling up on month, but it's keeping the product and keeping the store, and we get 24,088. So what this shows is it shows this group by cube construct really allows us to kind of go through and actually do the full kind of cube calculation. And it's a lot easier. You can use group by cube. You can use that over a Kimball approach where you're doing the joins. You can do that, but it's a lot easier, it really is, to just have one wide table. Okay, so that's kind of that's one of the main kind of like findings, or that's one of the main opinions now in practice, is that forget doing the joins. Now, does this result in much larger cubes on disk? Yeah, they can get much bigger, but there's ways that the implementations can compress these things and make them so that it's feasible. I mean, there may be, maybe, and you get a really specialized case where you want to implement a Kimball approach, but I think in general now you want to just go over to something like this. Now, what are the this is just kind of straight PostgreSQL here. Now, if you wanted to really let's see, I mean, if you really wanted to, I mean, let's put it this way, there are some additional things you can get, but it's not that much more, but it's some additional things you can get that kind of add on to this if you go to although I'm at a loss to kind of say exactly what it is, but what people do in practice is what they use Redshift. I guess you guys can see that. Okay. Redshift. That Redshift is Amazon's extension to PostgreSQL to support a little bit more cube functionality. I think most of it's about like ingestion and other stuff, but it's basically straight. You have a straight SQL interface into the cube, and you do this group by cube, and you're probably going to want, I don't know. I think that there's still a lot of people who do use a Kimball approach, but I don't think it's so that I agree with the DBT people that it's not necessary anymore. You just have some extra space. Maybe okay. Sorry, now I understand what I wanted to say. Redshift. All right, how do I say this in the time we have? I'll say it this way. From point of view of the SQL language and this kind of group by cube functionality, PostgreSQL is good enough from the point of view of just the syntax. It's essentially you can support all your kind of visualization tools through this kind of syntax. That's fine. But what is not, now we're talking about big data. This is big data that's coming in. That's, this is like this little dinky example I had of just like several products and several stores and over kind of a short time span. But what if it really kind of gets up to like we have 10,000 different products and we have, so many different channels that we're selling them through. It just becomes this giant bloat. This central table, the central fact table becomes enormous. Okay. So traditional databases like PostgreSQL are what they call row stores. So when you look on disk, and we'll talk a lot about this later, when you look on disk, each record is kind of first, so if we look at the sales thing right here, if you look on disk, you're going to see the date, then the PID, then the SID, then the quantity. Then you're going to see the date, the PID, the SID, the quantity. That's a row store because each row, like this might be memory location on disk or something of particular address. Then this is this address here is greater than that. Address here is greater than that, and basically they're storing the whole tuple, the whole record across at that address. I hope that makes sense to people. All right, I really do. So that's how PostgreSQL organizes data. Now Redshift, which looks essentially identical to PostgreSQL in terms of the syntax and all this other stuff, it does it a different way. It does a column store. All right. And so now what a column store says, it has a vector that the first element of the vector is this date, then the second is this date, then the third is this date, et cetera, et cetera. Same with PID here. The first element is this, second element is this, third element, fourth element, blah, blah, blah. And same with SID. So you have 4 separate vectors which represent the data. And it's just kind of like some offset into those vectors. You can reconstruct the actual value for the tuple. Okay. Now you can do a lot of things with that. Like for instance, right here, do we need to actually have full long, integers to represent this vector here? No, because we only have 3 distinct values. So we can use some kind of bitmap representation, some kind of bit representation to represent this vector. Likewise, maybe even with the dates. And then another thing also might be, let's say that we just had, let's just say that we had like most of these were zeros. Let's just say that most of these were zeros. Then what we could do is we could maybe even have a more of a complicated way to represent quantity, which is like a run length encoding, which says, let's say that we had the quantity, we had like 20 different quantities, we had 50,000 rows. Maybe the best thing to do is to say, okay, go in. So instead of representing the quantity as like 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and then, and then finally a digit, you just say, okay, the quantity is represented as 45 zeros, followed by the number 117, followed by 500 zeros, et cetera, et cetera. That's called a run length encoding. So that's a different way where you get high compression of the actual, of these vectors. So that way of organizing things into a column store, that's what something like Redshift, that's what they do. And then they wrap it up and make it look almost exactly like PostgreSQL. because it is based on PostgreSQL. But it's just under the hood, it's doing that. And of course, between a row store and a column store, if you're doing a lot of these aggregation, a lot of these analysis queries, I mean, the column store just completely crushes the row store in terms of performance. So that's why you have things like Redshift. There's other ones. Let's see. There's another one. I believe it's Snowflake. And then you have another thing. You have the whole Power BI stack, which is built on top of Microsoft SQL Server. But I would say that Redshift is kind of probably, if anybody wants to do a warehouse, oh no, time is up. If anybody wants to do a warehouse project, then my strong suggestion is that you get yourself a free tier AWS account, because you can still, and you do it over Redshift if you're going to really have lots of volume. Okay, anyways, guys, that was kind of a whirlwind tour of this whole thing. I hope that it was somewhat instructive. Yeah, so next time.